Hey there, in this video we are going to look at evaluating variables within multi-step multiple equations. So we have some problems where we give you a variable and then we give you an equation where you might have to plug in a variable, find another variable, then use that new variable value to plug in and find another one. And it kind of just works like a snowball off of each other. So use one to find another, use that to find the next one, and kind of work through. So let's take a look at example 1. So on example 1, it says given y equals 18. So here we see that y is equal to 18. Anywhere there's a y, we can go ahead and plug in 18. So I'm going to start with the z equals y over 9. So in that z equals y over 9, we can plug in the 18 up here in for y. So without even reading the rest of it, I know right off the bat if I need to, I can plug that in. And if you continue to read, it says, and x equals y times z. So we see another y. So eventually, if we need to, we could also plug that 18 in for the y over here, because 18 is the value of y. Now they're asking us for the value of x. They want to know what is x. And the only place we see x is here in this final equation that's given to us, where we're multiplying y and z together to find x. But we don't know what z is until we plug 18 in for y and find what z is. Then we'll be able to take that value and plug it in for z here. So when we're given y is equal to 18, we can go ahead and find z by doing 18 divided by 9. So we're plugging in that 18 in for y. 18 divided by 9 is 2, so we know that z is equal to 2. So now we can add to our list of known information that z is equal to 2. So if we know that y is 18, we can put an 18 right here for y in place of y. And then for z, if we know we just found out z is 2, then we can put a 2 in place of z. So now to find x, all we do is 18 times 2. And 18 times 2 is 36, so x has a value of 36. Now, similar concept here in number 2. We know we're given that a is equal to negative 3. So anywhere there's an a in any of the other equations, we can put negative 3 there. So here we know that if a is negative 3, b is 4 times a, and c is b divided by a. So we already know that a is equal to negative 3. If we want to find b, we're going to use this equation right here. So we're going to use b equals 4 times negative 3. 4 times negative 3 is negative 12, so b is equal to negative 12. So we can add that to the list of information we know. If we know that a is negative 3 and b is negative 12, we can go ahead and plug those values in. Make sure you plug the correct one into the correct spot. So if you look over here at this equation, we see that b is actually on top. So be careful that you do plug in the correct number in the correct spot. So b is going to be negative 12 up on top. And then a is going to be negative 3 on bottom. And when you do negative 12 divided by negative 3, a negative divided by a negative turns into a positive. So this is actually going to be 4. And so c is equal to 4 in this example. And then finally, we have example 3. Given that L is equal to 4, right away we know anywhere else that we see an L, we can put a 4 there. Notice that these next equations are a little bit more complicated than what we saw in the first two examples. So they tell us m is equal to 2l plus 7 and n is equal to m over 5 plus 6l. They want to know what is the value of n. We're going to follow the same steps. There's just a little bit more to it. So l equals 4. We're still going to plug that 4 in for l in this the second equation here. M equals 2 times 4 plus 7. 2 times 4 is 8, plus 7 is 15. So here m is equal to 15. So we can add that to the list of information that we know. So now again, we can come to this third equation And right here where this m is, we can go ahead and we can plug in 15 for that m. So right here, we can replace m with 15. And then right here where this L is, we can replace that L with 4. So this is 6 times 4. So we have n equals 15 over 5 plus 6 times 4. Now, when you do this, we follow our order of operations. There are parentheses if you write them as parentheses. You could write those parentheses just as multiplication with no parentheses there, just 6.4 with the dot in the middle as multiplication and drop the parentheses. But either way, there is no simplifying to do within the parentheses. No exponents here, so then we move on to multiplication and division from left to right. So we would divide this 15 over 5, and we would multiply this 6 times 4. 15 divided by 5 is 3, plus 6 times 4, which is 24. Add those together, because that's the only operation that's left, and we get n is equal to 27. So in this style of problem, remember that you're given typically one value, and then you're going to plug that in. So you're going to be given a value, you're going to plug that into the next equation, and then you're going to get another value, and then you're going to plug both of those in to your third equation. So that's typically the process. You're given one, you plug it in to find a second value, and then plug in the first and the second value to find the third value, and that third value is your answer. So that's the pattern that you see here. Obviously, you could have a slightly different problem, but that gives you an idea of what to follow for the procedure for these types of problems.